Hi there, so today we're going to look at Pascal's triangle. So I'd like you to take a minute, just read this paragraph, pause the video, and we'll move on. Okay, so what you see here is Pascal's triangle forming. A few things to notice. It starts with a 1, and then the next row here has 1s. A lot of patterns, we're going to talk about them today. Let's use this little applet, and what do you think goes here? So if you look at the hint, look at the outer diagonal. 1, 1, 1, 1. Well, let's try 1 here. The next number that goes into Pascal's triangle here, let's check out hint 2. So look at the second diagonal in either direction. So here's the second diagonal. Goes up by 1, goes up by 1, goes up by 1. So 4 plus 1, let's go with 5. And for this spot, let's see what hint 3 says. Look for the pattern in the third diagonal. Okay, here's the third diagonal. From 1 to 3, we go up by 2, 3 to 6, we go up by 3. So let's follow that pattern and go up by the next number. 4, 6 plus 4 is 10. Continuing with that hint, let's look that we go along this diagonal, and it goes up by 2, 1 to 3, and it goes up 3 to get 3 to 6. So let's add 4 to 6, put 10 here. Okay. And continuing that same approach, goes up by 1, goes up by 1, goes up by 1. This is 5. And on the ends here, let's try that. It seems to be working. Great. This triangle has a lot of patterns, as it's explaining up here. Here's one of them. So these are rows. That's a row, that's a row, that's a row, that's a row, etc. This is the 0th row, first row, second row, third row, fourth row. So look for a pattern, or patterns, and let's investigate some more. So here's an interesting pattern. If you read each row as a number, so this one here is number 1, number 11, 121, 1331. It's interesting to see that if you raise 11 to the power 0, power of the row, it's the same number. Continuing with this pattern, you'd think it would break down. I'd like you to, maybe this is sort of like an enriched activity. Just read through this, and it's kind of neat. We're not going to cover this too much detail, so I'll just skip ahead and you can pause. Okay, here's a pattern we're going to use. Let's move on. It's called the hockey stick pattern. So if you notice, you form a hockey stick, you add up the stick, 1 plus 2 plus 3, you always get the blade. 1 plus 2 plus 3 plus 4, that's 10. And another one, 1 plus 2 plus 3, that's 6. You can reverse the stick. Take a minute to read the palindrome property. In a nutshell, race car is a palindrome. You read race car one way, and you also read it the other way. Here's a neat one. Was it a cat I saw? Was it a cat I saw? That property, this palindrome property, exists in Pascal's triangle. It goes 1, 4, 6, 4, 1, and repeats backwards. 1, 4, 6, 4, 1. Every row is like that. In the next unit, we're going to look at things called combinations. So this lesson actually ties into combinations. You don't need to be too worried about that right now. We will get there. to get out of this slide is here are the rows. So we use n for rows. N equals 0 is this row. N equal 1, 2, all the way down to 5 here. And it's this first number, row 1, row 1, row 2, row 2, row 2, etc. Row 3, 4, 5. Okay, again up here it's going to talk about combinations. We're just interested in understanding that we use n for rows, and look here, r for columns. So this is column 0, column 1, column 2, etc. So the way we denote a position in Pascal's triangle, for instance this one, this is row 3, column 1. Row 1, 2, sorry, 0 base, that's important. It starts at 0. 0, 1, 2, 3, and then it's column 1. So here's column 0, and then column 1. So this is position row 3, column 1. In the next screen, we're going to find the position for row 4, column 2. So you see it's building the rows. We want row 4, column 2. Here come the columns, and there you go. Right here, so the 6. So if we had to find row 5, column 4, let's do the rows first. Row 0, row 1, row 2, 3, 4, 5. Oh, wait, I just did the columns. Be careful. What you want to do, rows are this way. Row 0, row 1, row 2, row 3, row 4, row 5, and then we want column 4. So here we go. Column 0, column 1, column 2, column 3, column 4. Okay, don't get caught. I know you're used to rows maybe should have the n, but we use n for rows and r for columns. Alright, another pattern. Let's find the sum of each row n in this Pascal's triangle. So row 0 here, 1 plus nothing, 1. 1 plus 1 is 2. And we just keep doing this. 1 plus 2 plus 1 is 4. 8, 16, 32. So what pattern do you notice in the sum of each row? So take a minute to think about that. Pause the video and we'll move on. Here it is. The sum of any row in Pascal's triangle is 2 to the power n, where n is the row. And you can see here row 0, n equals 0. 2 to the 0 is 1. So what application could we use with this interesting pattern in Pascal's triangle? Let's try an example. Okay, so here we go. My brother's given me a list of 10 CDs that he'd like for his birthday. I have not decided how much money I want to spend on him, or even if I will buy him anything. So how many combinations, that's the word we'll use later in Unit 2, but for now, how many, I guess how many combinations really is the word of the requested CDs that you might purchase. And it's super simple. All you do is the following. You use Pascal's triangle, and the shorter method, which I'll show you here, is you take 2, because you have a choice. Take it or not take it. Take it or not take it. That's a choice of one or the other, 2 things, and you get to make that choice 10 times. And it's also the sum of the 10th row in Pascal's triangle. Okay, the additive property. And this is true. This is the most important pattern we're going to use in Pascal's triangle. So please take a minute to read this, pause the video, and when you're ready, move on. Alright, let's move on with the additive property. So here you have Pascal's triangle, and we've got 0th row, 1st, 2nd, 3rd, 4th row generated. How do we generate the next row? Well, it's an iterative process. This triangle will always have 1s on the outside, But to get the next values, so after you get your 1, you want to get this 5, you add the previous 2 in the row before. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then 1 goes to the outside. It really is that simple. Okay, so grab your skeleton notes for lesson 4 on Pascal's triangle, and we're going to take up this short lesson. So here you have Pascal's triangle. We've discussed it. Let's look at it a little more focused on some examples and neat activities or applications that come from it. So Pascal's triangle, it's an iterative process of repetition of steps and dates back to the 17th century. Here's how we generate Pascal's triangle. Okay, the first 2 rows contain only 1s. Row 0 and row 1. And each row always begins and ends with a 1. So let's add that on the next row. Okay, so we've added the 1s that are on the ends of the next row. To get the next values in that row, each term is the sum of the 2 terms immediately above. So we're in this row. Here's the terms that are above. You have to add them up. 1 plus 1, you put 2 there. Okay, there you have it. We have row 2. 1 plus 1 gives 2. 1's on the ends. So take a minute to do the next row and continue it for the next 4 rows. You can always reference the Pascal's triangle at the start of these notes. Another way to describe the values in Pascal's triangle is to use a notation. So here's our notation. Term that's in Pascal's triangle T, row N and column R, and we can denote every one of the values in Pascal's triangle using this format. Okay, so for row 0, this would be term 0, 0, which means row 0, column 0. This just continues as we see our triangle. Term 1, 0 is the first row, 0th column, and then this next one is the first row again, and then the first column. And this labeling repeats. Here you would have term 2, 0, 2, 1, and 2, 2. So if we want a general formula for term n, comma r, it looks like this. So let's write a formula for term nr, and here it is here. So term nr is equal to the following. So that reads as term n, comma r, nth row, rth column, is equal to the term in the previous row and the previous column, plus the term in the previous row and same column. To see this with an example will help, so let's try that. So for example, let's write term 10(7) from Pascal's triangle using the terms from the previous row. First thing you want to do is take a look at term 10(7). What's our row, what's our column, and use the right letters. So here we find n equals 10 for row 10 and r equals 7 for column 7. We then take our general formula here and write it down. And wherever we see an n or an r, we substitute accordingly. So here we go. We want to find term 10(7), and we substitute where we see an n, we put 10, r we put 7, etc. And there's no like final answer, but we recognize that like no numerical final answer of what the term is, but this shows how it's calculated or found. So term 10(7) depends on term 9(6) added to term 9(7), and we saw that earlier with the additive property, where in the row previous to the row you're in, you have to add the 2 terms to get the next term. Let's try another example. This is very similar to what we did a little earlier in the video. So if we ask, what is the sum of the numbers in each row? Well, here's our Pascal triangle. And the sum, this is a sigma symbol rather. It means sum of row 0 here. We see it's just 1. And then for row 1, 1 plus 1 is 2. Row 3, 1 plus 2 plus 1 is 4. And if you follow that, just like we did earlier, you recognize that the sums follow a pattern. And the pattern we discussed earlier was 2 to the n, where it's power 2 and, excuse me, base 2, power to the n, where n is the row you're considering. So in the following example, we're going to use the properties we know of Pascal's triangle to find some missing numbers in a similar triangle. It's not Pascal's triangle. As you'll see here, it doesn't look exactly like it, but we use the same additive property to do this. So we're asked to do the following. Fill in these blanks. Let's talk about that. First off, you'll do 36 plus 84 to get that value. So 36 plus 84, just to be sure here, 36, you grab your calculator, right? And you get 120. Now to get this spot, you take 120, add it to 210, and you're going to get 230 here. Okay, let's talk about this one. We know 84 has to add to this value to give 210. So we'll just do the reverse. We'll do 210, and we'll subtract 84, and we'll find that this value is 126. Okay, how about you pause the video and try and find the next two values, and when you're ready, come back and I'll put the answers up. Okay, there you have it. It's 252, and then 462 here. You have to do the additive property. So 126 plus 126, 252. 210 plus 252 is 462. For example 3, let's talk about this in class. But if you want to try it, you use the general formula and look for the pattern, and then you have to rearrange the equation. Example 4 now. We want to find the sum of the 10th row of Pascal's triangle. We've done this a bunch of times, so all you're going to need is the following. The sum of the rows in Pascal's triangle is just 2 to the n. And here we have n equals 10, so we do the following. Substitute 10 for n and work that with your calculator. $1,024. Okay, last example we'll do. So let's determine the row number for the row sum of 6, 5, 5, 3, 6 in Pascal's triangle. You're going to need your sum formula. So the sum is 65, 536, and that's equal to 2 to the n. N is the row. To solve this, you could use logarithms, but since many of you might not know those, you'll have to do, you can do guess and check here. So grab your calculator. 2 to the what is equal to that. Okay, so let's try 2 to the 12. Not big enough. 2 to the 16. There you have it. So n equals 16 will solve this. And that's the row, the 16th row, the Pascal triangle. All right, there you have it. So we want to practice these. There's a lot of types of questions you can see. So I'll show you what the homework is, and you can get on it. Bring your questions to class. We'll take it up, and I look forward to some of these discussions. So when you visit my website, which you should be familiar with now, come into grade 12 data management. We're in unit 1. And it's a little squished, but one sec. And here you can see Monday, February 11th. Okay, you can download the handout, section 4.4 with answers. And the handout says page 6, 7 on number 1, 2, 3, and 6. So good luck. Here was the skeleton notes, as I call them. If you happen to not know that, that's where they're always going to go. And then once they're filled in, I post them filled in. So best of luck. We'll see you in class. Talk soon.